This is part 3 of the lecture on the spherical Earth. In part 1 of this lecture, I briefly described that the distance that an observer is from the horizon depends upon that observer's elevation above the surface of the Earth. Making a calculation of the distance of an observer to the horizon is easy to do. It just involves a little bit of Pythagorean theorem. Here is that calculation. Okay, so determining the distance to the horizon. Okay, so let's say it right here is the Earth, like so, and then let me draw the following line. And on this line we have here two distances. First of all, this right here is the radius of the Earth, as originally first measured by Eratosthenes. In modern measurements, the Earth's mean radius is 6,378 kilometers. Okay, and then this distance here will be the distance that an observer is above the surface of the Earth. So let's refer to this distance here as d. Okay, and then we have the positioning of the horizon. How would you determine that on this diagram? Well, what I would have to do is draw a line from the observer that is tangent to the surface of the Earth, say at this location, for example, like so. So then therefore, if you were here, you would not be able to see this portion of the Earth because it would be below the horizon. So then therefore, this right here is the unknown in this calculation. That's the distance from the observer to the horizon. Let's label this distance here as x. Okay, and then lastly on this diagram, and thereby forming a right triangle like so, is this distance right here, which is also just equal to the radius of the Earth, like so. And now we just use a little bit of Pythagorean theorem here, where the unknown in this calculation is x. Okay, so setting up Pythagorean theorem, we first of all have r squared plus then x squared. And this then equals the hypotenuse squared. A hypotenuse is the sum of r and d. Like so. And now we just solve for x. So subtract the r squared to the other side. So, and then just take the square root of both sides now to find x. Like so. The way this works mathematically is that the greater your elevation above the surface of the Earth, the greater the value of d, the larger the value of x. I described this in part 1 of this lecture when describing the observations of Catalina Island, for example, as seen from here in Pacific Palisades. Okay, now let me go ahead and choose a number here for d. Let's say, for example, that you're standing on the beach, you're looking out over the ocean. What is the distance from you to the horizon? Well, let's say at the average height of a person above the ground, let's say that the average height of a person is, say, 1.7 meters. So let's go ahead and set d equal to 1.7 meters. And then we have the radius of the Earth as 6,378 kilometers. I do, however, have to convert that into meters in order to make this measurement. Okay, so R is 6,378 kilometers. Oops, 6,378. Like so. Let's multiply then by the following. We have 1,000 meters per kilometer, like so. And then if you do the math here, this is 6.378 times 10 to the 6th meters, like so. So now I'll go ahead and plug everything in, including the distance d is 1.7 meters, to get a result for x. When I do, I'll end up with a distance in terms of meters, and then I'll go ahead and convert it into kilometers. Okay, so let's go ahead and plug in now and just find what x is. So I have the square root of the following quantity. So first of all, I have r plus d. So 6.378 times 10 to the 6th plus 1.7. Okay, and then I take that value and I square it. And then I subtract from that the distance r squared. So minus 6.378 times 10 to the 6th squared. Close my parentheses now and take the square root of the whole thing. And when I do, I end up with a distance in terms of meters of 4656.8 or so, 0.7 rather. That's in terms of meters. That's the distance x. Like so. So divide by 1,000 to convert this into kilometers, and this is roughly 4.6567 kilometers, like so, which is just a couple of miles. Okay. Okay, that concludes this lecture here on the spherical Earth.